All right, boys and girls, welcome back to the drive-through. We're here with a little 7-2 action. This is a hard proof. I'm going to walk you through how I'm going to do this, and then I'm going to erase that because I'm not going to have enough room. But essentially, let's mark what we're given. EF is the median to AC, which means we're going to eventually know that. CBD is congruent to ADB, and as you can see, that's like an N. And since those are congruent, then those are going to be parallel. Okay. You're going to have vertical angle. Well, first of all, and then it goes CD is the base of an isosceles triangle. So those are congruent. So we have that, which is going to lead us to that by transitive. What we're going to end up being able to do is use angle, angle, side to prove the left triangle congruent to the right triangle. And then we'll do that with CP, and we'll say the diagonals are congruent. So now that I think about it, I don't even think I'm going to need that. And I'm glad I talked it through. So I got to prove the left triangle congruent to the right triangle by angle, angle, side. So, EF is the median. Well, here, I'm going to squiggle the givens because I honestly am going to run out of space. And now I'm going to mark my diagram as we go. So, we do have this. I know that AF is congruent to FC. And that would be definition of median. And now I'll mark that. Okay. Now CD is the base of an isosceles triangle. So then FC is congruent to FD. By definition of isosceles. Okay. Now I'm going to say that angle AFD is congruent to angle BFC. AFD is congruent to BFC. That's vertical angles. All right, let's see. Let's mark that. And now I think we've got, check me out here, angle, angle, side, angle, angle, side. So now, yep, I can do it with my new theorem. I can prove that triangle AFD is congruent to triangle, let me get this right, AFD, CFB by AAS. Okay, so then I can say BF is congruent to DF by CP. Then I can say AC is congruent to BD by segment addition. Okay. Then I can say that step 8, ABCD is a rectangle. And the reason is if a quad has congruent diagonals. Oh no, I need to prove it's because it could be an isosceles trapezoid. Oh. Okay, we're not done yet. I'm going to have to erase that step. First I got to prove it's a parallelogram. So, oh no, I can do this. Check this out. I'm going to put p-gram here to abbreviate this video. Okay, look. If a quad has congruent diagonals that bisect each other, then it's a rectangle. So not only do we know that the diagonals are congruent, but we also know that they are cut each other into equal parts, and that's the difference between a rectangle and isosceles trapezoid. I would never put this proof on your test. Boom! Reading time. Boom!